Alright then, hello guys. So we're going to be doing another Flare On challenge, and the challenge we're doing today is going to be called Flare On 12, and we're going to be doing Project Chimera. So with this specific Python project, you're going to need to do a Python virtual environment. The reason why is because when I first downloaded the file and ran the code, which was project chimera.py, so if I run in Python 3, project chimera.py, we see this exception string says syntax error, f string expecting. So doing a bit of research and also reading the write-ups, it turns out that this specific Python code only runs on 3.12 and higher, and specifically only on 3.12. In my case, if I check my Python version, I see that I'm currently on Python 3.11.4. So we need to set up a Python virtual environment for specific versions. So I looked it up, and there's multiple people that use UV, which is a kind of like a Python virtual environment where you're able to, I guess, specify the specific version of Python you want. In my case, since I already ran this and already done this step, I'm not gonna, I guess, show you guys that. So you guys could probably figure that out. So uh, first I want to activate my virtual environment. So I think if I just lsla dot v v activate c dot cd dot vmv. I think we just need to activate this bin ls. Yeah, just activate. So source, I think activate. So now we activated our Python virtual environment. As you can see, that vmv is now current, and if we check our uv and then run, and I think Python version or umv, I think it's Python version. I always forget how to do this. I just did it beforehand too, which is pretty funny. UV Python. My name UV Vim. Yeah, it's whatever. Deactivate it. Managing, inspecting environment, pip list. Check the version of Python on in UV. UV Python list, I guess. Mm, 3.12. That's currently the one I'm on for this virtual environment. So let's see this. And I guess UV pip list. So I guess also when I initially ran the Python code, I need to have these libraries installed, which I did already. So I guess giving you guys a heads up on, like, if you manage to get this to run and you see that you still see errors, it's probably because you don't have the correct pip libraries installed for in order for to run the program. So now if I do, I think it's uv run and then project chimera.py, we get this, which is fine, which is what we're supposed to get. So now from here we get to, I guess, look inside the binary file itself, or not the binary but the Python script, and see how it's built. So if you look right away, you see that this thing is first decompressed and it's loaded as sequencer code. So what we could do is basically, I think, comment this part out and just print out the sequencer code. I could be wrong, but oh no, we could disassemble the sequencer code and that we could see it in real life. We could write the code, or we could just ask ChatGPT to do it ourselves, which we're gonna do. So we're just gonna open up ChatGPT and then give me the raw code. Load, execute, runs into memory. analyze it, you could do the this module. So that's us analyzing the code and inspecting bytecode safely, which we're gonna do. In this case, we already have the object code because it's already loaded. So we're gonna go nano project chimera.py. I think it's sequencer code. Sequencer code. It loads it into code object. Do we have Marshall? zlib. Marshall loads it, but it loads it, but sequencer code. But we want to put in a disassemble, so we'll just do. Except that this we just use this dot this. That should be good, and then import this for disassemble. In my case, I don't need to run pip install because I already had it installed when I was trying to solve this challenge a lot earlier. Python 3 uv run project chimera.py, and we see all the disassemble code right here. So now we see this. Now I'm gonna ask it, can you rewrite it? So putting up Chimera, I guess the bytecode or whatever this is, the disassemble code. So I'm gonna ask ChatGPT, can you disassemble the middle part? It's out of place. No. Not disassemble, but no, don't skip. I want it to match the rest, so decode it. No, don't. I can't help. It's okay. I guess it's not able to do it, but I think you can make it. So, can you rewrite it? Can you decode it from base 85, then to zlib, and then to Marshall? Oh yeah, that's fine. This is good enough. So encoded catalyst string. But I decoded everything, so we'll just probably just grab this. Nano solve. Nano project Chimera. That's that. Home. Hidden equals that. Then end, and then go right here. Then what it's gonna want us to do is basically base 64 encode it. Catalyst string. Let's just call it hidden. Hidden. Base 64 and then base 65 decode, and then what we want to be able to do is go back right here. Compressed catalyst. Marshall genetic code. And then from right here, it's zlib decompress. So we already zlib decompressed it, and then we want to be able to load it. Marshall load, which matches this right here, catalyst code object, and then we want to disassemble this this catalyst code object. Now if you write this Python 3. Imported nano solve project Chimera, import base 64. Base 64. Now we got it. So this is the full code right here, decoded. So I'm gonna ask it to reverse engineer it. Give me the original, I guess, the original or what it's supposed to be. Let's go right here. Can you give me the original code, but rewrite it in Python. Yes. It's a related source code. So now it's able to rewrite it as Python how we want it to see. Okay, so this is basically what's asking us for. So Catalyst core decoded payload logic. So it says right here, decodes Marshall core. It creates, if it matches a hardcore, it creates a from the OS user. If it matches a hardcore with the user, it decrypts the hidden formula, displays it with cal save. If it fails, print failure brand. Okay, so it says right here, I am the lie. The secret formula is decrypted formula. We work backwards. Decrypted formula is basically, it doesn't mention it right here. No, it doesn't. So decrypt the formula. Okay, so right here, there's a decryption happening, but there's still more to it. Authentication. So there's some form of authentication where user signature is equal to lead researcher signature. Lead researcher signature we have, but how do we get the user signature? User signature is basically some kind of XOR function. Happens here where it XORs the current user that's, I guess, logged in. And then it runs the XOR function. And if it matches the lead research signature by a bunch of XOR functions, that means we pass the authentication. So we have to find a way to get the current user. But in our case, since this is basically a XOR, we can just apply this logic to the current user, which is, we could apply this we could basically just run the reverse of this code right here, where it just runs it for this lead signature, I'm assuming. So now if we just grab this, and not to make it weird, but Python interpreter, it's whatever. Python interpreter. I don't think we need to use like anything fancy. Then just user signature. I think we just do that lead signature, which is fine. Then we just copy that. I think we just do this. I'm pretty sure we can. We just copy and paste it inside. Pretty sure. Print user signature. You could also do this in your, I guess, your own local environment, but in my case, I'm just trying to get this over with and expand indent. No. Golden transmutation. So that was the user, that was the username that we needed to have. And then from right here, it says, once user signature is equal to league signature, authentication success, then we grab the current user and we run this argc4 decipher with the encrypted formula, and then we ask it to decode. So we could basically copy this, but we can't use it here because it's using an arg4 library, which is right here. But we could probably do it locally on what we have right here, because I think if we check it, uv pip list, I have it installed. Yeah, arg4. I needed to do it when I solved this challenge. So now if we run nano solve.py, wait, no, nano solve.py, and then we just from arg4 import rc4. In our case, we could just copy the code that is right here. Copy, go back right here, arg4, decipher, current user. User is equal to, and then whatever we got from our code previously right here, golden transmutation, copy. It might be, we might need to put it in bytes, but we'll see right now. Let's see if we could get away just having it like that. Print arg4 decipher, and then make sure the indentation is correct so we don't get like any kind of errors. Python uv run solve.py unexpected error. arg4 Oh, decrypted. Yeah, and now it should decrypt, hopefully. Oh, encrypted Chimera formula on that. We just need to copy it from our code. And then we could probably get it from right here. You could find it somewhere around here. Right here, encrypted formula, which is in bytes. Ooh, we might need to turn the thing back into bytes. Nano solve.pi is equal to that home, and then we put encrypted Chimera formula, and then it's not going to be arc4 decipher, it's going to be the decrypted formula right here, and then we get the arc4 cipher. Might turn this to bytes just to be safe. And now if we run this Python, no, UAV, so we can run it in our virtual environment 3.12 uv run solve.py, and we get the flag. The alchemist secret formula is Flairon.com. So see, look how easy it was with, I guess, a little bit of AI, where it was able to help us, I guess, speed up the process of getting the flag. It was mostly used for, I guess, deciphering and writing the needed functions to decipher the bytecode back into assembly and then back into Python. And also it helped us identify what was disencoding, which was base 85, which I did not know until I dropped it into AI. And from there, I guess, even went further to tell us that how to decrypt it also from zlib. So there was two types of encryptions, both a base 85 and also zlib. So if we check our code for Project Chimera, which was what we started off with, you can see that, oh yeah, this right here, the hidden one, which was this value right here, it was base 85 decoded, and after that we decompressed it with zlib, and after that we were able to load it back as disassemble it, load it as Marshall code, and then after that disassemble it. And from there we asked AI or ChatGPT to be able to rewrite the code into Python to make it easier for us to read. And from there we were able to understand what was going on, what kind of authentication they were using, and from there we were able to get the flag. So yeah, hope you guys learned something, or helped you guys, I guess, use AI in a way to speed up solving these types of challenges. And I'll see you guys in the next one. Peace.